Students, today we are going to continue with the lesson magnetic effects of electric current, and in particularly we will be talking about force on current carrying conductor and magnetic field, and also some part of electric motor. Okay, so this is part number 4. In the last session we had learnt about magnetic field due to current through circular loop, and also we had talked about magnetic field due to current in solenoid. So today we will start with force on current carrying conductor in a magnetic field. मतलब अगर करंट फ्लो हो रहा है किसी कंडक्टर से और वो मैग्नेटिक फील्ड में है तो वो कितना फोर्स अप्लाई करता है, कैसे अप्लाई करता है, किस डायरेक्शन में अप्लाई करता है, ये सब कुछ हमें सीखना है. We have learned that an electric current flowing through a conductor produces a magnetic field. The field so produced exerts a force on the magnet placed in the vicinity of the conductor. Vicinity means near to the conductor. Okay, let me take a pointer. Now, the French scientist André-Marie Ampère suggested that the magnet must also exert an equal and opposite force on the current carrying conductor. Okay, so we already know that electric current that flows through a conductor produces magnetic field. ये हमें पहले से पता है. ठीक है, अगर कंडक्टर से करंट फ्लो हो रहा है तो वो अपना एक मैग्नेटिक फील्ड प्रोड्यूस करता है. द फील्ड सो प्रोड्यूस्ड एक्सर्ट्स अ फोर्स ऑन द कंडक्टर, और ये जो फील्ड है वो मैग्नेट पे फोर्स अप्लाई करता है अगर मैग्नेट उसके नज़दीक है तो. ठीक है, तो एंड्रे मारे ने क्या इनमें सजेस्ट किया था कि मैग्नेट मस्ट ऑल्सो एक्सर्ट एन इक्वल एंड अपोजिट फोर्स ऑन द कंडक्टर. मतलब जैसे कि करंट का एक मैग्नेटिक फील्ड होता है और वो मैग्नेट पे फोर्स अप्लाई करता है, वैसे ही मैग्नेट भी अपना जो फील्ड का फोर्स है वो उस कंडक्टर में अप्लाई करता है. सो इट इज इक्वल एंड अपोजिट बोथ द फोर्सेस. सो दिस इज अ वेरी फेमस साइंटिस्ट André-Marie Ampère. This is his picture. Students, talking about André-Marie Ampère, he has great contribution in mathematics and physics. Okay, he was born in a rich family, but he had not attended any proper school as such. But he was very much interested in studies. So, though his parents they were of the point of view that he should study the subject of his interest, so they didn't put him in any school, but he was very much interested in studies, especially in physics and mathematics. So he did quite a lot of research even at the age of he was not even 20 at that time. At that time he had proposed a research paper. He had put forward his research paper in mathematics. Okay, he has a specialty in conics in mathematics, so he was very famous. And in physics also we have dedicated one unit, the current itself, the unit is ampere. It is named after this scientist. Okay, so let us move on further. So what we have to do is to demonstrate this theory proposed by André-Marie Ampère. What we have to do is we have to take a current carrying rod. If you can see here, this AB is a current carrying rod. It experiences a force perpendicular to its length and the magnetic field. तो ये जो फोर्स एक्सपीरियंस करता है ये परपेंडिकुलर रहता है किसको, उसके लेंथ को, रॉड के लेंथ को, एंड ऑल्सो टू द मैग्नेटिक फील्ड. ओके, नाउ हियर टू शो अ मैग्नेटिक फील्ड वी हैव shown here a magnet. Though we have not suspended it, this is just for demonstration purpose. It is a schematic diagram. We have to make certain arrangement to suspend this magnet. Okay, well, the displacement of the rod in the above activity suggests that force is exerted on current carrying aluminum rod when it is placed in magnetic field. Okay, it also suggests that the direction of force is also reversed when the direction of current through the conductor is reversed. मतलब अगर मैं करंट का डायरेक्शन चेंज करूँ तो फोर्स का डायरेक्शन भी चेंज होता है. Now, changing the direction of the field to vertically downwards by interchanging the two poles of the magnet, what happens if we do this? the force direction can be given by Fleming's left hand rule. Okay, so according to this rule, what we have to do is stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular to each other. तो thumb, then forefinger and middle finger, ये कैसे करना है, stretch करना है in such a way that they are mutually perpendicular to each other. If the first finger points in the direction of magnetic field, second finger if it is in the direction of current, then thumb will point in the direction of motion or the force acting on the conductor. So that's how we use Fleming's left hand rule. Using this, if we know the direction of magnetic field, direction of current, then we can predict the direction of the force, okay, by using Fleming's left hand rule. Applications, talking about applications, devices that uses current carrying conductors and magnetic fields include electric motors, electric generators, loudspeakers, microphones and measuring instruments. All these devices use this particular theory. Okay, now this is a schematic diagram of electric motor. यहाँ पे अगर आप देख सकते हो, यहाँ पे मैग्नेट का नॉर्थ पोल है, यहाँ पे साउथ पोल है, यहाँ पे एक रिंग है, दो इट इज नॉट सर्कुलर बट वी स्टिल कॉल इट एज रिंग, एंड दिस इज अ स्प्लिट रिंग. यहाँ पे अगर आप देख पा रहे हो ये स्प्लिट रिंग है, यहाँ पे बीच में स्प्लिट्स है. Then Y and X are brushes, then this is the axle in between, and then this is attached to the external electric circuit. Now today we are not going to be discussing in detail about this particular topic. We will see just the construction part of electric motor. An electric motor is a rotating device, as we all know, that converts electrical energy to mechanical energy. Electric motor is used as an important component in electric fans, refrigerators and mixers. Okay, so in all these devices we find electric motor. So this is a structure. An electric motor is as shown in the figure over here. It consists of rectangular coil A, B, C, D, A over here, B, C and D, okay, of an insulated copper wire. The coil is placed between two poles. दो पोल्स के बीच में, नॉर्थ और साउथ पोल के बीच में ये कॉइल रखी जाती है, such that arm AB over here and CD are perpendicular to the direction of magnetic field. Then the ends of the coil are connected to the two halves. किसको कनेक्टेड होते हैं, P को और Q को कनेक्टेड होते हैं of a split ring. Okay, the inner side of this house are insulated. इसका जो अंदर का पार्ट होता है ये कैसे रहता है, इंसुलेटेड रहता है. Okay, and they are attached to an axle. ये बीच में axle है. The external conducting edges of P and Q touch two conducting stationary brushes X and Y. ये stationary होते हैं, they don't move. Okay. So that was the structure of electric motor. Henceforth, after this, when we will meet in the next session, we will be talking about the working of electric motor, or how does it function, that we are going to study. But for today, we are going to end this session with the last topic that we discussed, the structure of electric motor. ये हमने आज डिस्कस किया, अगली बार हम फंक्शन देखेंगे. ठीक है, so let us see the homework. Write a short note on force on current carrying conductor in a magnetic field. इस पे short note लिखना है आपको. Force on current carrying conductor in magnetic field, जो पहला वाला टॉपिक हमने किया उस पे एक short note लिखना है. Then second question is state Fleming's left hand rule, जो हमने अभी अभी डिस्कस किया था. Then list out the devices that uses current carrying conductors and magnetic fields, तो ये भी मैंने बताया है आपको. And then lastly you have to draw a schematic diagram of electric motor. Okay, so this was homework for the day. So that was all for the day. Thanks for attending this session. I hope you learned few things, and I also hope you enjoyed the session. So see you in next session with another topic. Until then, take care. Bye bye.